I'm back. Hello again. Last talk for me. So I'm going to talk now about the Office OpenXML file format. And one thing I wanted to note before I got started is that right at the beginning of this, I did post in the resource page of the other talks, or at least of the Excel one, these two links. I just wanted to make a note that I have these also repeated in the OOXML talk. So if you need these, they're right up front here. This is the forum and the doc help email alias to post a question to my team. Okay. So what we're going to talk about today is we're going to do an overview of the OOXML format. We're going to talk a little about what it is, a little history of how it came to be, how it started, and the standardization kind of it. In talking about that, we will talk about the Office versions that support it. And then we'll do a brief tour of the actual standard. This is the ISO IEC 29500 and ECMA 376 standard. And then we'll see a little bit of it in action. I'll just open a couple files, some test files, so you can see what it looks like. We'll tour around a little bit, and I'll show you what that looks like. Okay? And then I've also got a couple pages on tools and resources that you can use to support or to actually work with the format. So what is OOXML? It also stands for Office OpenXML. Sometimes we just call it OOXML or OpenXML. At the most fundamental level, OOXML is based on the W3C standard for XML, which is the extensible markup language. And this differs from binary file formats significantly in that it also, although it may not be as compact, just as XML itself may not be as compact or concise, it's both human and machine readable. So that's a significant difference. And it's easily consumed by many different applications and services with code libraries on different platforms that are readily available. So OOXML can be used to represent spreadsheets, word processing documents, and presentation documents. And these can be consumed by both Microsoft Office as well as third-party software. Just a note here that OOXML is the current Office format. As you'll see in the coming slides, we'll talk about, after we talk about the history, we'll talk about the current support level. And this is the latest Office file format. So the binary file formats that I covered in the last three talks are considered legacy, even though we do still get questions about those, and there are a lot of binary file format files out there. This is the current file format that you want to use to be up to the latest. So each OOXML document is contained in a zip file. And these are parts, and this gives it the compactness that just raw XML didn't have. It also gives a nice logical organization. And the file extensions for OOXML are docx, xlsx, and pptx. Now we're going to talk more about these parts as we get later into the tour of the format. So the history of OOXML. So in 2000, the first XML-based file format for Excel was released and was used by Office XP. This was followed by a corresponding Word format in 2002. In 2003, Microsoft released a version of Office which incorporated these new XML formats, which also included Visio and InfoPath XML formats. There was no PowerPoint XML format at that time, and there were limitations to the format. For example, VBA macros and charts were not included in the spreadsheet format, and there was poor backward compatibility. Word 2002 couldn't open Word 2003 XML files without a third-party tool. The XML format also did not use the zip compression to reduce the size and provide the organization of the file. Then in 2005 and 2006, Microsoft co-sponsored a new version of the XML specification called Office Open XML. And they used the ECMA International Organization to do this. And this produced the ECMA 376 specification. And then in 2007, Microsoft Office 2007 was released, making OOXML standard or the default file format. And then in 2008, the Joint Technical Committee of the ISO-IEC approved the standardization of OOXML, and the ISO-IEC 29500-2008, which signified the year it was released, specification was produced in 4 parts. Both the ECMA 376 and ISO-IEC 29500 are maintained. Here you see the 2 current versions or editions, the 4th edition of the ECMA 376 and the 2012 edition of the 2500 standard. Both contain 4 parts and they are equivalent specifications. And these can be downloaded electronically for free if you go to the ISO website. So Office 2007 first supported OXML, the default format, as a default format, and it used the ECMA 376 standard at the time, because that was all that was available. Office 2010, when Office 2010 released, it supported the ECMA 376 standard as well, but only in read mode. It was able to read the ECMA 376 standard. It was able to read the ISO-IEC 29500 strict conformance, and we'll talk about what strict and transitional mean. But it was also able to read and write the transitional format, which gave it fidelity or compatibility with older versions of Office. And then the 2013 version of Office reads and writes the strict conformance of the 29500 standard. And you can see this by going to the File Save As in 2013 menu item, and you'll see a strict OpenXML presentation for PowerPoint. And then just a note here, there's a reference at the end of this. I've footnoted this as a reference, blog by Doug Mayhew that describes the transitional and strict terminology. But as kind of an overview, transitional compliance was provided as a way to allow applications to emit documents that have the most fidelity with the older formats. So part 4 of the OOXML, and I'm going to talk about part 4, I'm going to talk about each of the parts in sequence. Part 4 of the OOXML standard contains the transitional elements that match up with the components of the older formats. And this allowed migration to the new format without losing backward compatibility. Strict is provided as a subset of transitional conformance. So everything that's in strict is also in transitional. And part 1 of the format of the standard describes the strict elements. So when you download the 29500 standard, you'll see that there are 4 parts. And we're going to take a look at each of those parts and what they are. So as we mentioned in the last slide, the first part contains the fundamentals of the strict conformance of the actual markup languages for word processing ML, Sheet ML, or Spreadsheet ML, and Presentation ML. It contains over 5,000 pages, so this first part is very, very large. The overview in section 8 is very helpful, so that can guide you. And this includes the markup languages that are included in this are the word processing ML, as I said, Spreadsheet ML, Presentation ML, but it also includes Drawing ML, which is roughly equivalent to the role that MSO Draw played in the binary file formats. And for each of these sections, for each of the markup languages, I'll call them MLs, for each of these sections, there are sections describing the package and part summaries, so how these things are packaged, how the file format for, say, a word processing ML document are packaged, and what the parts mean. And those are in sections 11 through 14, corresponding to each of the MLs. And then there are the reference materials, and those are in sections 17 through 21, corresponding to each of the MLs listed above. So because the standard is so large, it's helpful to have some starting points. And you could read the entire thing. It's 5,000 pages, but most of us don't have the time to read that. So here's some pointers for each of the MLs, each of the markup languages, to get you started. And these are just some important sections that I think you'll end up using as you get started. So for word processing ML, for example, the document XML specification, that part is in 11.3.10, and then the body paragraphs and runs are in 17.2 and 3. And I've listed the other important ones: sheet.xml parts, slide.xml part, and then the schemas. Since this is XML, there are schemas that describe the elements and what types they can take in valid ranges for values and things. Those are in Annex A and B in both the W3C version and the RelaxNG version of the schemas. But important to note is the primer, which is in Annex 11. This is a fairly detailed introduction to the markup languages And I highly recommend going and using this and reading through it. It gives a lot of good information and a lot of good introduction and practice in using the markup language. So these are the highlights of part 1 of the standard. So part 2 of the standard contains packaging information. This talks about the actual package itself. So it's a zip file, but what's in it? So here we see a few things that are of interest to us, like first, the part model. This describes how parts are named, what type their content is, and how they are addressed. And then the second part of interest here is the physical package description, which, among other things, describes how the part names get mapped to zip files or to zip item names. So within the actual zip package, the different item names and how the parts are linked to those. Part 3 talks about extensibility, and this is kind of an interesting part. This is mechanisms used by the implementers to allow, or by implementers of the standard, to allow new features and elements to be added to OOXML while allowing consumers who don't understand those new features to continue to consume the format and yet be interoperable. So the consumers can be aware of the new elements and use them, or degrade gracefully when they're not aware of them. So here are some examples, some of the important examples here. We have elements or attributes like the ignorable attribute, which allows the consumer to ignore an entire namespace. So when it comes upon this namespace in the actual document, it can just say, I don't know. If I don't know this, I can ignore it. If I can't process this namespace, then I can ignore it. That way, it can still process the whole document and get what it can out of it. Process content is kind of like ignore, but it's saying don't just ignore the element, but process it as if it was in the outer element. So elements in XML are nested, and when you go deeper into the nesting, you get into a namespace perhaps that you don't understand. The process content the attribute can be placed on an element to allow a consumer to know that they can process this one particular element as if it was in an outer element, not in the inside element where the consumer doesn't understand it or doesn't understand its semantics. And the must understand attribute tells the consumer that they have to throw an error before processing any of the elements in this namespace or any of the misunderstood elements of this namespace. So this is forcing the consumer to know everything in this namespace or throw an error. And then the alternate content element. So the alternate content element provides choice and feedback content that gives the consumer a choice of what alternate content to look at, or to fall back on some graceful. Thank you. that probably would help. Fall back on some alternate content that is like a graceful degradation. Okay. And then part 4 is the transitional. I mentioned this earlier. Part 4 is the transitional specification. It describes all the transitional migration features that allow new versions of the application to continue to be backwards compatible, as I said before, with older versions. And in this part, for each of the markup languages, you will find things like additional attributes or to existing elements or additional elements. There is actually even an entire namespace in this part, and that's the VML reference. Okay, so additional specifications that go hand in hand with the standard are the MS OI 29500. This is a set of implementation or behavior notes on top of the 29500 standard. Because OOXML is a standard, it's not meant to be implemented only by Microsoft Office. It's intended to be, implemented by third parties as well. There isn't specific information in ISO 29500 for Microsoft Office. So we have a separate specification that gives specific information about how Microsoft Office implements certain elements if it deviates or has some difference from the standard. And then, and these are generally included as collections of notes with headings that reference the sections in the standard. And then MS-ODraw XML and DocX, XLSX, and PPTX are all specifications that define extensions to the standard for a drawing ML, word processing ML, spreadsheet ML, and presentation ML. So let's take a quick look at what an example word processing ML document would look like. As you can see here, it's fairly straightforward. It's human readable, of course. This is XML. And we've got angle brackets and elements and namespaces. Here you can see the document element. This is the top of the document XML part of a word processing document. We can see a body, which defines the beginning of the body of the document. And then we have things like P and R and T. These are paragraph elements and runs and text elements. So it's, as you can see, it's fairly simple to look at and kind of get a feel for where things are in the document. It's not like the binary file formats. Okay. So how do we look at one of these OOXML documents? How do we inspect them? Well, they are zip files, so all you have to do to inspect them is rename it as a zip file with a zip extension and extract the contents. And then you'll see a folder with the package contents, and the contents become a file system hierarchy of files and folders. So now what we can do is we can take a look at one of these and see what it looks like. So I will show you. Let me just extend or change my monitor here. So now you can see what I'm doing. Don't want to see that or that. Okay. So for example, I have a sample docx file here. This is a word processing ML document. If we want to look at that, all we have to do is, well, let's take a look at what's in it right now. We can open it with Word. We don't need that. And you can see that it's just some runs of text. Some kind of nonsense runs of text. Okay? But now we can just kind of crack this open in OOXML and see if we can find where all that is. So I'll make a copy of this and I will rename it. And I'm going to rename it to plugfest underscore test. And then put a zip extension on it. And I'm going to accept the change. Now we have a zip package format for this file. So we've turned it into a zip file, which it actually already is. Now if I just double click on this, I see the parts that are in this OOXML package. And I can start taking a look at some of these. And one thing I notice here right off the bat is something called content types. This defines the types of all the parts in the package. So I could look at an XML file just using, say, Visual Studio. Pull this in. Oops. Sorry, I have to extract it first. I always do this. Okay, and I'm going to extract it to here. Rid of that. Okay, now I have it extracted. And notice that I've extracted it, and I'll pull this down here so we have them side by side. That's already open. Now I can take a look at this. There's the content types.xml part. If I reformat that in Visual Studio, I can see all of the elements. Okay. And so one thing we notice is we have a bunch of part names and content types. So this defines what type, what kind of MIME type, because it uses a similar scheme to the MIME types. It defines what types are in each of the parts. So if we look at, for example, here, so if we look at this, oops, not that guy, but the document right there, that is the document XML part, which will contain our body of our document. And if we go over here and look at the content type for it, we see that it is a, oops, it is a, hold on, this guy right here. Word processing XML, or word processing ML document main XML. So it's added the XML specification onto the word processing document main. So we know that that's the type of document, that's the type of content that's in there. So this is kind of a handy place to come when we first open a package so we can tell what types are in there. So let's see what else is in here. If we go down now into the Word folder, we see the document XML part, and we can open that. I'll reformat that. And now we see the entire word processing ML specification for the main part of the document, which is the document XML part. And as you notice here, we have the body again. So we have this, body. Here, and then we have paragraph and runs and text, various things like that. One of the things that I wanted to show you, we were talking about the extensibility. Notice along the top here, we have these XMLNS namespace specifications. Or actually, I'll just zoom in here. Whoops. See these? So these guys right here. Sorry. These guys along the top here. And these are actually specifying the namespaces that are used in the document. But if we look out a little bit further here, way out at the end, we'll see something that we saw in our slide, and that is the ignorable attribute. So these are word namespaces that are used within the word processing ML document, but which some applications may just be able to ignore if they don't understand all of the elements of these. Okay, so now that means whenever we see these tags used to scope, basically scope elements, if we don't understand these are for later versions of Word that maybe we might not understand, W14, W15, we can ignore those. And you'll see here, like this right here, that's an example of an element, para ID. That's an example of an element 14 scope, which if our application doesn't know what that is, we are allowed to just ignore that. And that allows us to be more compatible with Word. Okay, so we also have something called the rels part. This defines relationships. So wherever we see a relationship ID, and actually I'm going to go ahead and, at this point, I'm going to go ahead and look at the Spreadsheet ML and PowerPoint. There's just a brief slide on each of those. And those will actually have pictures in them, and the pictures are identified by relationships. And so then we'll be able to actually match up with the relationship. So let's go ahead and do that. Switch back over. Okay. Oops. Got me all the way back down. Right here. Okay, so this is an example of Spreadsheet ML. As you can see, we have a worksheet element, we have dimension elements. The dimension element actually refers to what are the valid dimensions, the valid range of cells within a spreadsheet that actually contain data. So that's kind of like the cell table that we refer to in the binary file format. And then sheet data, and within the sheet data nested element, we've got rows and cells and values. So let's take a look at one of these and see if we can match up some of the values and relationships here. So we'll put aside our doc. We'll now take a look at this one. Actually, we'll close out these guys. Make a copy. Call it zip. Yes, we want to rename it. Now remember, we have to extract it first. We'll take the default. Okay, now we have this file. We'll put this here for reference. And now we have the contents of our spreadsheet. ML looks just like word processing ML, at least in the structure of it, except for we have an Excel folder instead of a Word folder. But we still have content types, which define the actual types of the different parts. And we can go in and take a look at this. So here we've got the parts of the Excel workbook. And if we go into the worksheets, we should see a sheet XML, sheet 1 XML. So that's the only sheet that we happen to have in this particular spreadsheet. And actually, I should have brought this up first. Let's look at what it looks like in Excel. As you can see, this is kind of a strange little spreadsheet. It's got some label cells in it, a couple of value cells, 1 and 2, and then it's got a picture stuck in it. So that should at least be kind of interesting. We can see if we can find that picture in the OOXML. And actually, it's not too hard to find. A lot easier than the binary file format. Okay, so let's take a look at sheet 1 XML. Okay, reformat. So here we have our sheet. You see we have worksheets, a worksheet element, and then we have some sheet views, which are defined dimensions and views for sheets, and then we've got the sheet data for this particular sheet. Okay, and then we have rows and cells, cell specifications. The row specifications say what row we're in, and then the cell specification tells us what exact cell we're in. This one's A1, and remember in the spreadsheet we had a value of 1. We had a value of 2 in the second one. But what's interesting here also is that in this cell, if you remember, we had here, whoops, no, not you. We had these labels, SDF and blah, right here and right here. So if we're looking at, and that's A3 and B4. And if we look at A3 and B4, they have numbers in them, the values of numbers, but actually what these are indices into the string table for this spreadsheet. And the way we know that is the type of this cell has T equals S. That means that this is a string. And that means that we have to go and look up the string in the string table. So let's see where that is. And that's going to be in our shared strings XML. And there they are. And they're indexed by, if we look at the sheet XML, we saw 0 and 1 right here and right here. And they are indexed accordingly, SDF and blah, 0 and 1, just in their order in the string table. And interestingly enough, this element looks familiar. It looks like the string table, shared string table name that we had in the binary file format. just use a similar name. Let's see if we can find that picture. So let's go back to the sheet. And drawing. So we see this drawing element here. And notice it has an RID1. It has a reference ID and an RID. This is a relation ID. So based on the relationship model within OOXML, we know that we can go to the relationships part in the drawing part of this document, and we can look for it. So let's see where that is. So let's go into our drawings, go into our rels, and if we pull this rels file, here's the RID1. So that rels part contains the relationship we're looking for. And then what does that map to? It maps to this image. Sorry, this image right here. And that just happens to be the image that we have in our file. That happens to be that. Okay. Let me go back. So this next slide, and I won't take you through opening and inspecting presentation ML because there's really nothing new. We've already seen all the stuff that I would do here as well. But this is just an example. You see that in the slide part, the top element is a SLD, P, SLD. P is the namespace for, or is the identifier for the namespace for presentation. And then we have, as we mentioned in the binary file format, is also true in the OOXML format. Presentations are primarily made up of drawings. So the first thing we see here is a shaped tree, or SP tree, that P SP tree element. And then under that are a series of nested elements, PSP, and those are shapes. Within those shapes, of course, you can also have text boxes and things like that. So we see below here P text body, and then there's a run with some text in it. Okay. So it really is pretty intuitive and pretty obvious, and so mapping that with the specification becomes, although the specification is very big, it becomes really pretty simple. So drawing ML is used by all three of the markup languages, as I mentioned before, and it has some interconnectedness, just like with ODraw and the binary file formats. For each ML, it's a little different. They use slightly different naming. All three of the other MLs can make use of basic drawing ML elements to add shapes and images and charts and things to their documents. So, for example, a presentation might have a picture, and we saw that presentation might have P pic, a P colon pic, or something like that. In the Word or in the spreadsheet, we saw drawing. That was the element it used. So they're all just a little bit different. And then use this relationship ID mechanism, which we saw in the spreadsheet ML. The same thing applies in slides, in presentations. One thing that you'll find also is that word processing ML and sheet ML and spreadsheet ML also have ways to specify things like where the drawing item is located, how it fits into their own items. And so they have their own drawing namespace specified within the drawing ML reference. And for Word, that's the W:\drawing namespace, and then for Excel, that's the XDR. So if you're looking at a spreadsheet ML or a word processing ML and you're trying to figure out where they're doing their drawing, sometimes it can be a little bit confusing how they specify shapes. Go and look at the drawing ML and you'll see two separate topics or two separate sections for word processing and spreadsheet ML. So just to kind of finish up, programmatically, or building an OOXML document programmatically, the way to do that is to use something like the OpenXML SDK. And we have links to that on the resource slide. The resource slide on this presentation is fairly large. It's got a whole bunch of links in it. This can validate your document once it's built, so there are tools to validate it, including, and that's included in the SDK. And it's able to read the strict conformance OOXML, that's the part 1. And it supports the Office, it supports Office 2013. The other way to do it is by hand, which is much more tedious, but it is doable. Not like the binary file format, which is extremely tedious. So what we have covered, we've defined what OOXML is. We've given a brief history behind the standard. We've taken a little bit of a tour of the standard specification documents, the different parts, and then some kind of simple examples of what they look like, breaking them open and taking a look at what they look like. So any questions?
Hello, Tom. You've said that Microsoft has made some extensions to the OOXML standard, including Microsoft ODraw XML and the Microsoft DOCX, etc. So are these extensions follow the extensibility rule of ISO 29500?
Yeah, they do.
So which category they belongs to? One is ignorable, process content must understand.
There are different ones. Yeah, they're not. It's not like all one thing. It depends on what the functionality or feature is.
Okay, so for Microsoft Office, it can process all the standard features as well as the extensional features as well.
Right. Right.
Okay. So is it is it possible to allow the user to do the extension? I remember that in Microsoft Word 2003.
I'm sorry. Can you?
In Microsoft Word 2003. It has a function called Smart Document, which allows you to define users' XML schema and then to incorporate into the Word document. So is it possible to use this facility, do the same thing in Microsoft Word 2010, 2012, 2013.
Mm-hmm. So
is the Smart Document facility still available now, or not?
Are which documents available?
Smart Document. Smart Document is a feature of Microsoft Word 2003.
Yeah, I'm not sure I understand what you're asking.
Okay, doesn't matter. 智能文档，智能文档。in Microsoft
I'm
2003.
not sure.
Okay.
Are you saying March documents or?
就是智能文档，智能文档可以用 XML 的schema出来定义广告或者 Doesn't matter. Okay.
Well, I can come and you can explain. Okay, any other questions?